Look around your kitchen right now. Your sink. Your appliances. Maybe the utensils in your drawer. There's a good chance the same gleaming rust-proof material is staring back at you from every direction. And it's done that so thoroughly, so quietly, that anything without it almost feels outdated by comparison. But here's the real question. How did one metal manage to quietly take over hospitals, kitchens, skyscrapers, and factories all at once? And is it actually as revolutionary as we treat it? Or did we just never bother looking for anything better? Welcome back to The Story Behind It, where we dig into the hidden engineering behind the objects surrounding us every single day. If uncovering stories like this is your thing, hit subscribe now, because this one's a good one. Every piece of stainless steel begins its life as something far less glamorous. Iron ore, pulled straight from the Earth's crust. This ore is packed with iron oxides, and before it can become anything useful, it has to be stripped down to pure iron. That extraction happens inside a blast furnace, where the ore is heated to staggering temperatures, nearing 1,700 degrees Celsius, alongside coke, a carbon-rich fuel, and limestone. Under that kind of heat, the ore melts, and carbon from the coke reacts with oxygen trapped inside it, releasing carbon dioxide and leaving behind pure molten iron. This liquid iron, known as pig iron, becomes the raw foundation everything else is built on. But stainless steel is so much more than plain iron. Its defining trait, that near magical resistance to rust and corrosion, comes down to one critical addition: chromium. Here's the science behind the shine. Chromium reacts with oxygen to form an incredibly thin, essentially invisible layer of chromium oxide across the surface of the steel. That microscopic barrier is the entire secret. It's what stops oxidation in its tracks and protects the metal underneath from ever breaking down. To get chromium into the mix, it's introduced as ferrochrome, an iron-chromium alloy, added directly into the molten iron. For steel to earn the stainless label, it needs to contain at least 10.5% chromium by weight, though the exact percentage shifts depending on the specific grade being produced. But chromium is only the beginning. Depending on what the final product needs to do, other elements get folded into the mixture too. Nickel adds extra corrosion resistance and gives the surface a brighter, more polished look. Molybdenum strengthens resistance against pitting and crevice corrosion, especially valuable in harsh, high-chloride environments like the open ocean. And manganese boosts overall strength and hardness. Every one of these additions gets measured with extreme precision, because even the smallest miscalculation can completely change how the final steel performs. Once all those alloying elements are blended into the molten iron, there's still work to do because impurities inevitably creep in during the process. That's where argon-oxygen decarburization, or AOD, comes in. During AOD, a mixture of argon and oxygen gets injected directly into the molten metal. The oxygen reacts with carbon and other impurities, forming gases that escape the mixture entirely, while the argon helps regulate temperature and prevents the chromium from oxidizing too aggressively. What comes out the other side is a precisely controlled, refined stainless steel, exactly matched to the properties it needs. If you love watching raw materials transform into the objects we rely on every day, that's exactly the kind of story The Story Behind It exists to tell, so make sure you're subscribed for what's next. Once refined, the molten stainless steel is ready to take shape, usually through continuous casting, where it's poured into water-cooled molds. As it cools, it solidifies into long, continuous slabs or billets, which are then cut down into more manageable sections. This method is favored industry-wide because it allows manufacturers to produce enormous quantities without sacrificing consistency. From there, those slabs move into hot rolling. They're reheated to roughly 1,200 degrees Celsius, then pass through a series of powerful rollers that gradually compress the steel, thinning it out and shaping it into whatever form is needed. This step does more than just shape the metal, It actually refines the internal grain structure, improving overall strength. Depending on the intended use, the steel can emerge as sheets, plates, bars, or wire. After hot rolling, the steel still isn't ready. Its surface is rough and oxidized and needs serious cleanup. That's where pickling comes in. The steel gets submerged in an acidic bath, typically a combination of hydrochloric and nitric acid, which dissolves oxide buildup and surface contamination, leaving behind a clean, smooth exterior. For products where appearance really matters, think high-end kitchenware or architectural finishes, an additional step called electropolishing may follow, pushing the surface to an even higher shine. From there, the steel moves into final finishing, which can include cold rolling to nail down exact thickness and surface quality, annealing to relieve internal stress and improve workability, and various surface techniques like brushing, grinding, or polishing. Depending on what's needed, the finished steel might come out with a mirror-like gleam, a soft matte texture, or a distinct patterned surface. Even after finishing, the process isn't finished. Quality control is critical. Samples get pulled at multiple stages of production and put through rigorous testing. Chemical analysis, mechanical strength testing, and microstructural evaluation, all designed to confirm the steel meets exact specifications with zero defects that could compromise its performance down the line. Only once it clears every one of these checks does the stainless steel move forward, shipped out to manufacturers who transform it into the products surrounding us every day. A kitchen appliance, a surgical instrument, a structural beam holding up a building, even jewelry. That versatility is exactly what makes stainless steel so valuable, proof of just how much precision and engineering goes into something we barely think twice about. From raw iron ore buried in the earth to the polished surface sitting in your kitchen right now, stainless steel's journey is a masterclass in materials science and precision engineering. Whether it's the chromium fighting off corrosion, the nickel adding durability, or the rolling process nailing the exact thickness, every single step exists for a reason. So the next time you spot a gleaming piece of stainless steel, take a second to appreciate just how far it traveled to get there. If this kind of story pulled you in, that's exactly what we do here, every episode. Hit subscribe, and we'll see you next time on The Story Behind It.